So I'm really excited about a few things to demo this week. Finally, all of that coordinate system nonsense is over. Progress is really being made now that my calculations are working out as expected. In this video, I want to show that I've gotten the trajectory control working, and I really like how that turned out and where I can go with that. So if I'm moving the slider, I'm setting only the position of the robot torso and each foot in XYZ space. The inverse kinematics then updates the joints for me, and the green target is created. Now, the new trajectory control creates all the mid-states and animates them in white. The trajectory control takes velocity and acceleration parameters into account, so the transition between states are smooth. There are a number of velocity profiles, but I'm using a simple rounded trapezoidal one here for now. So we can see the standing and sitting transitions are much smoother than the last video. I was pleasantly surprised how this code worked out. I can't wait to demo my next steps, where I set up multiple target states and have the trajectory planner morph between all of them. The blue arrows are showing some large torques in the knees and ankle joints, which is fine as these joints are holding up the robot. Now taking a look from the bottom, I see I've added contact detection in the feet, namely those cyan-colored rectangles. We can see that when the robot is held at an angle, to lift the leg, that part of the foot is no longer in contact, or at least sometimes only partially in contact. The blue rectangle that wraps around those cyan rectangles is the robot's support polygon. If the robot's center of mass is within the support polygon, then we can assume that the robot is in stable balance. I'm actually processing the URDF mesh model to determine the shape of the foot. Also, the default stance is determined by looking at angles and distances in the URDF model, so all of this code will work on humanoids, hexapods, or quadrupeds. The robot state object now stores a ton of useful data. Joint, segment positions, velocities, accelerations, dynamic forces, contact data for limbs, support polygons. It's a complete snapshot of everything, and it can represent both the current and the desired state. So this brings me into the trajectory control, being able to use this state data to generate in-between states. There's still some occasion where the robot state gets a little bit out of whack, and this is affecting my balance algorithm. It basically boils down to not locking the feet to the ground, and the IMU motions are confusing the balance algorithm. It's evident in the RViz visualization where we see the feet sliding all over the place. Obviously, this isn't matching physical reality. Now that I have the ground contact data though, I think I can fix this in the next round.